and Newton's law of cooling.
A chemist was ordered to make 40 gallons of solution containing 85% of chemical Y and 15% of chemical Z. He already have 100 gallons of solution at 27 degrees Celsius containing 50% of chemical X, 35% of chemical Y, and 15% of chemical Z, and a separate pure chemical Y. 50 gallons of chemical X will completely evaporate after 10 minutes if its temperature is at 100 degrees Celsius or higher. He heated the solution in an apparatus at 150 degrees Celsius. After 10 minutes of heating, the solution was observed to be at 50 degrees Celsius. He waited until chemical X evaporates completely. Then he introduced pure chemical Y into the resulting solution at a rate of 6 gallons per minute, while stirring the solution and allowing some of the solution to flow out at a rate of 4 gallons per minute. At least how many minutes does he need to accomplish his task?
The first step is list the given. So for 0 minutes, the temperature is 27 degrees Celsius. For 10 minutes, 50 degrees Celsius. And for time t, 100 degrees Celsius. The temperature of the surrounding is 150 degrees Celsius. So for the general equation for the Newton's law of cooling, dt over dt equals kT minus Ts. Then put the limits and integrate it. So, kuha niyo ba? Oh my God! I get it! Ay, wala akong masabi talaga. Kayong mga supervisor, After integrating, you'll substitute the limits and you'll get ln of 100 over 123 is equal to 10k. Find k equals k is equal to 110 ln 100 over 123. Next, you'll find t. In order to find t, you'll get the limits from 27 to 100 and 0 to t. After getting the limits, integrate it. After integrating it, substitute the limits and you'll get ln of 50 over 123 equals to kt. Then find t. You have already your k, 110 ln 100 over 123. Then substitute it here. And you'll get t equals to 43.58 minutes. So that's the time for heating. Sean and Dennis, kayo naman sumagot.
This part of the problem is solved using chemical solution, where we need to get the time it takes to get the required concentration of the solution. So here are the givens. Time to evaporate is equal to 10 minutes. Well, since 50% of the solution already evaporated, 50 gallons is left. Y naught is equal to 35 gallons. R sub 1 is equal to 6 gallons per minute. C1 is equal to 1. R sub 2 is equal to 4 gallons per minute. Since R1 is different from R2, we solve for the rate of change per unit of time, which is 6 minus 4 is equal to 2. Now we integrate, then we get V is equal to 2t plus k. Now to get k, we use at time t is equal to 0, V is equal to 50. So we get k is equal to 50. Now we know that c is equal to y over v. Now we use dy over dt is equal to r1 c1 minus r2 c. Now we input r1, which is 6, times c1 is equal to 1 minus y over v, which is 2y over 2 plus 25.
So to solve this equation, we need to find the integrating factor, which is equal to the integral of 2 dt over t plus 25, which is this one. And it is equal to e to the ln of t plus 25 squared. And the integrating factor will be equal to t plus 25 quantity squared. And to solve this, we need to use the technique in solving linear in one variable. And we just use y and substitute the integrating factor, t plus 25 quantity squared is equal to the integral of q of x, which is 6, times the integrating factor t plus 25 quantity squared dt. And we integrate the right side of the equation, and the equation will become y is equal to t plus 25 quantity squared is equal to 2 times t plus 25 quantity cubed plus x. To solve for the value of x, we use t is equal to 0, y is equal to 35. Substituting these values, we get the value of x as negative 9,375. Substituting the value of x, we get the new equation y is equal to t plus 25 quantity squared is equal to 2 times quantity t plus 25 cubed minus 9,375. Since we know that C is equal to 0.85 is equal to y over v, which is equal to y over 2t plus 50, we get another expression for y, which is equal to 0.85 times quantity 2t plus 50. We substitute the expression for y to our previous equation, and the equation will become 0.85 times 2t plus 50 times t plus 25 quantity squared plus 2 times t plus 25 quantity cubed minus 9,375. And we do some algebraic operations, and we get t is equal to 6.50 minutes. This is the time it takes to get the required solution, the required concentration of the solution. And to get the total time, we add the time for heating, evaporation, and solution, which is equal to 59.98 minutes, and it is approximately 60 minutes. Thank you, Miss.